looked at a rock and wondered how it came to be? The story begins about 4.5 billion years ago, as gas and dust come together to form the rocks that make up our planet. Created from elements forged far off in a galaxy, rocks really are the stuff of stars. And so are we. Rocks, and the minerals they're made of, tell us the story of our planet. Look closely. Atoms are the building blocks of all matter. Combined, atoms form molecules. Minerals are made up of billions of molecules, which are often arranged in crystal structures. Minerals can crystallize from semi-molten rock called magma. When magma cools and solidifies, it forms igneous rocks, one of the three main rock types: igneous, sedimentary, and metamorphic. Granite is an intrusive igneous rock, commonly found on the Earth's continents. It has large crystals because it cools slowly, deep below the Earth's surface. When a volcano erupts, lava cools quickly to form small crystals, creating extrusive igneous rock, like basalt. Basalt makes up much of the ocean floor, and also most of the moon. Over time, rocks are broken down by weathering effects, like water, wind, heat, or ice. Small fragments, known as sediments, wash into lakes, rivers, and the sea. Here, layers of sediments compact and cement together over millions of years to form sedimentary rocks, like sandstone. Limestone is another kind of sedimentary rock. It can form from the remains of marine organisms or from chemical reactions within sediments. Fossils in limestone are an amazing record of the past, revealing clues to changes of climate and the extinction of life forms throughout the Earth's history. Did you know the ground beneath your feet is constantly moving? The continents and oceanic crust are pushing, pulling, and sliding in a process known as plate tectonics. This heats and squeezes rocks, changing their form. Minerals realign or recrystallize to form metamorphic rocks. Slate, used in roof tiles, and marble are examples of metamorphic rocks originally laid down as shale and limestone. The way rocks and minerals change gives us a guide to their origin. A rock's size and shape, and the colour and arrangement of its minerals, help geologists distinguish between different types of rocks. Many layers of rocks create a section, like this. With practice, you can read a rock section like the pages of a history book that goes back billions of years, almost to the beginning of the Earth's history. What drives our cars, buses, and planes? Powers our electricity and allows us to cook our food and heat our water. Most of today's energy needs are met by fossil fuels, like coal, oil, and gas. These unique, high-energy fuels are non-renewable resources that took millions of years to form. About 2 billion years ago, marine organisms like algae and microscopic animals and plants died and settled on the ocean floor. Beneath other sediments in the ocean, and in the absence of oxygen, these fossils changed into a substance called kerogen. Under heat and pressure, kerogen gradually changes into oil or gas. The whole process usually takes at least 1 million years. At the molecular level, oil and gas are hydrocarbons made up of hydrogen and carbon atoms. The constant pressure and movement of the Earth's crust squeezes oil and gas through the pores or spaces within rocks. Some oil and gas reaches the Earth's surface and seeps out naturally into land or water. Often it is trapped beneath the surface by impermeable layers or rock structures, like faults and folds. Within the crust, oil or gas deposits build up and form reservoirs. Reservoirs are like vast sponges filled with oil and gas. They can be as large as a city. To find oil and gas deposits, geologists use a number of different survey techniques, including seismic surveys, gravitational surveys, and geological mapping. Seismic surveys use reflected sound waves to produce a 3D view of the Earth's interior. New technologies, such as four-dimensional projections and sophisticated graphic renderings of rock structures, are improving the way we find conventional oil and gas deposits. Energy resources that are currently difficult or expensive to extract are called unconventional oil and gas. In a world with limited energy resources, people are looking at more efficient ways of tapping into unconventional oil and gas, or at alternative and renewable sources of energy from biofuels or the sun. What do you think will be the energy sources of the future?